Good morning, everyone, and thank you for joining us today for the Improving Talks session. We're thrilled to have with us today Joe Brinkman to be speaking about cloud native development. And we look forward to learning more about how and when to use the cloud for our various development efforts. With that, Joe, I'll let you introduce yourself, so hand it over to Joe.
Thanks, Tim, and thanks everyone for joining us today on my talk on cloud native development. I appreciate everyone taking time out of your busy schedule and joining with us. My story with the cloud began probably a little over a decade ago as we were having to move an application that I was intimately involved with, a content management system called DNN, and we were moving to the cloud. And the question was, can we just lift this application and start delivering it in the cloud? And what will that look like for us? And we learned a lot of lessons as we did that. And we're going to be talking about some of that, some of what I learned there today. And so why this topic? Why is this, so important right now? And I think everyone realizes that the cloud is really a ubiquitous part of what we do in computing today. It is everywhere, from the apps we use that are served as software as a service, to the services that we consume as part of our own application. The cloud pretty much touches much of what we do in the computing world today for application development. In this talk, I'm going to share some of my journey and what I learned as part of that journey about how building apps in the cloud is fundamentally different than building apps that would be on-premise or in a traditional data center, and how you can leverage that when you're building your app. So let's hop into this a little bit. So a little bit about me. I am a director of consulting here at Improving. I've been here for about 3 years. Prior to that, and during my time at Improving, I architect and build cloud solutions for our customers. And prior to that, I was a co-founder of DNN, where I authored several books, spoke at many international conferences, and have been intimately involved in building cloud apps for the last decade plus. So I've been around a number of the cloud applications and a number of the cloud platforms for quite a while now, and have watched some of that transformation that they've been going through. So today, what I want to talk to you about a little bit is just set the stage for how did we get here where we're at today with clouds and cloud applications, and how is that fundamentally different than where we've been in the past in terms of computing and application development. I want to talk specifically about why the cloud is important and how it's different than maybe your traditional data center or your server running in the back room at your office, right? And then we're going to talk and dive into what it means to be cloud native, not just run in the cloud, but actually be what is the term of art, cloud native, and why that's different, how that's different. And then we'll look at some good practices around building cloud native application. So when computing started, we started with mainframes. We started with these big, expensive hardware, right? And our applications ran kind of in this back room that nobody could see, that you really didn't have a lot of interaction with. But the key there was, just the size and scale of the hardware itself kind of limited your ability to scale. These were often multi-million-dollar systems, and that were, if you ran out of space, if you ran out of disk space, if you ran out of compute capability, it was quite expensive to get more capacity. It often meant expanding buildings, expanding rooms, bringing in additional hardware. It was quite expensive and quite an elaborate operation. Today, we've shifted to more rack mounted or server-based compute, where the unit of scale has gotten smaller, the unit of cost has gotten smaller, and it's much easier today to deploy and deliver hardware than it was ever in the past. And it continues to evolve, right? We continue to find smaller and smaller compute units that we can use to deliver capability to our customers and for our applications. And we're now to the point where we can deliver what used to be a mainframe's worth of compute capability on a single chip or on a single motherboard, something like a Raspberry Pi, which are more powerful even than the systems we used to send men to the moon, right? So the cost has come way down. The size and scale of what is needed to run applications has come way down from what it was to begin with, right? And now it's real easy to add additional compute capability. The cost and size and space considerations of the past are no longer part of that. And if you look over the entire history of the compute of the computer evolution, you see this constant reduction in size, constant reduction in cost, even while simultaneously seeing greater and greater performance achievements from that same hardware. Similar to the advances that you see on the hardware side, you also start seeing some dramatic shifts in the operating system and software side of the house. You start with a physical machine. You start with OSs, where the OS is intimately tied to the operating system or to the hardware that it runs on. You have special drivers that are part of the operating system that understand the hardware, right? And that was kind of where we were in the 80s and 90s. And then we moved into this phase where we had this thing called a virtual machine, where we take that OS and that hardware and we virtualize the hardware. So now we could run applications kind of in a little sandbox that we could run different operating systems within that same hardware, and they would all think that they owned this hardware. And that was a huge leap forward, and you saw a lot of applications get developed so that they could run inside virtual machines, because we could spin up virtual machines and tear them down and make copies of them and do interesting things from an application architecture perspective by using these virtual machines. And finally, in the early teens, 2010 plus, you started seeing the use and introduction of containers, which is not only a virtualization of the hardware, but a virtualization of the operating system, where applications now were not sharing the operating system. At least they didn't think they were. They were kind of sandboxed in their own state within the operating system, within their own processes within the operating system, that kind of kept them isolated from each other, but still able to access the services of that operating system and the services of the hardware underlying that operating system. So these major advances also contributed to how we get to where we are with the cloud today. And they really have driven a lot of the discussion we're going to have around cloud. So one of the things to understand as we start moving into this cloud space, and we'll talk about this more as we go along, is this concept of scaling, right? And scalability. If you think about how did we scale when we had mainframes, right? Is that problem we talked about a little bit ago. It's that idea that in order to add more capacity, it required a lot more space. It required a massive cost investment. And it was not something that was easily undertaken. You think about it similar to skyscrapers today. If you want more room, if you want more office space, if you want more storage capacity, right, you have to build a whole new skyscraper to handle that. And so that unit of scale is very, very large and very, very expensive. And where we've gotten to today in terms of compute and in terms of storage is much more granular, much smaller, right? Our unit of scale has gotten to the point where it's easy to add on additional units of compute. It's easy to add on additional units of storage capacity. And so all of these things have made the brought costs very much down and made it more efficient for delivering the same capabilities. If you think about it, when I would add that whole new mainframe server, I might only need the first 5 or 10% of that to handle the additional capacity that required me to make my upgrade. The other 90% of that capacity that I had purchased just sat there unused, unavailable really for productivity purposes, right? Until you started filling that up and started worrying about, okay, we're going to have to expand yet again. As we bring the size and scale of that scale unit down and bring the cost of that down, what you see now is the cost curve follows very efficiently the actual usage of those resources. So you don't have a lot of wasted compute sitting out there unused, untapped, that you're paying for. Somebody else might be using that. Somebody else might be paying for it in their app. But for what you need and for what you're going to deliver to your customers, you spend a lot less, and it's easier to spin up and spin down, and we'll talk about why that is. So those are kind of historically how we got to this place, and this brings us to a discussion of the cloud and what that really provides for us and kind of where we go in terms of this cloud discussion, right? And cloud native, because in order to talk cloud native, we really first need to understand what it is to be in the cloud, what it offers, what some of the benefits are. And I'm going to touch on a couple of them here. There's 4 that I'm going to touch on today. There are many more reasons and benefits to being in the cloud. I don't have time to go over everything today. And in fact, one of my colleagues was just talking about one of them with me before this session. But if there's others you want to talk about, feel free to post a comment in the Q&A. So this question of why, and the first one is one that we've talked about before, and that's scalability. The cloud, because of the way the cloud is built and the units of scale that it uses, we have the ability to scale our application very easily to handle larger and larger workloads. I don't have to go out and let's say let's move things forward a little bit. Let's go back to the early 2000s before the advent of the cloud. If I wanted to scale my application, let's say my server, was starting to run 80-90% capacity, right? I would have to go out, purchase a new server. That might be a couple $1,000s, depending on the type of server. It could be $10,000, $20,000, $30,000 for some servers or more. And so I would have to purchase that capacity. I would have to wait for it to be delivered. I would have to provision that server. I would have to stand it up and add it into my data center. And that could take weeks or months, depending on your procurement process and what that looked like and what the expenditure was going to be for that. Very lengthy process still. With the cloud, it kind of takes away a lot of that cost and effort, right? All of that is handled by the cloud infrastructure. I just say, hey, I need another server, and I can have one up and running in a matter of minutes. So scaling my application to handle those larger loads is not something now where I have to plan weeks and months in advance, but I can plan just a few hours or a few days or a few weeks in advance, depending on the size and scope of the application that we're talking about. Okay, the other part of that is that the cloud gives me really two different levers that I can use for scaling in that environment. I can do what's called scaling up, adding more compute capacity to a single instance or a single unit. I can add more memory. I can add more storage easily. And I can just grow the size of those things, right? I may only still have one compute unit in process, but that unit might have 10 virtual CPUs instead of 2. I might give it, 64 gigabytes of RAM instead of 4 gigabytes, right? And I can do all of that usually with just a single switch or a single setting in the cloud platform. So that gives me that ability to scale up very easily. But the other thing, and the piece that really is where the cloud comes into its own, is this ability to scale out, right? I could drop in more memory in a server in a data center, and it might take me a couple hours, to acquire and deploy that memory. Whereas acquiring and deploying new servers was a very lengthy process still even then. But in the cloud, that's not the case. In the cloud, deploying a new server is, again, a matter of minutes. Yes, there may be some planning involved in terms of the app and the app configuration, but overall deployment, scaling out in the cloud environment is one that happens quite naturally and quite easily. And in fact, I tend to favor using smaller, lower compute capacity units and just scaling out rather than scaling up, because it's a more natural fit in the cloud for how we scale applications. The second area that we look at in the cloud and why the cloud is beneficial is around reliability. And this is the ability of that application of those resources to always be available. You can think of it like dependability. You can think of it like a really fine Swiss watch, right? And that it's always going to work. It's very precise, very dependable unit. And the same is true of the cloud if you build your applications to take advantage of the platforms that already exist. Most of the platforms that are out there today run in either 3 or 4 nines, some of them in 5 nines of availability. And what that means is that you can count on less than a handful of minutes of outage on a monthly or on an annual basis, depending on the particular SLAs you're getting from that cloud provider for that particular service. That is something that is often overlooked when people. I've had discussions with individuals in the past that say, well, I could run my own server in my own data center for a lot less than what I pay for these cloud servers. And the difference is that when you run it in your data center, you're not getting the same reliability guarantees that you're getting from that cloud vendor, right? For you to run your own server in your own data center actually means you've got to run multiple servers in your data center to account for the case where one of those servers, gets a power spike and takes out a drive or a controller in the server, or some process in the server, crashes the hard drive on that server, and now you've got to rebuild that server. So there are lots of cases where we don't realize that it's not an apples to apples comparison to say this server sitting in my back room is the same as a server sitting up in the cloud, because those reliability guarantees that the cloud provides us, and those are baseline across all of these cloud providers. The other area is elasticity, and this kind of goes back to some of what we talked about before. All of the cloud providers and the cloud in general is built around this concept of being able to spin up and tear down services very quickly and very efficiently, so that it can bring new processes online, bring new applications online, or new instances of your application online as they're needed, as the scale of the application says, hey, I'm running out of resources, give me more, right? The cloud can scale up because it has very, very large capacities behind the scene that are just waiting for you to call on them, right? And then you get billed for what you're actually using. And then as your usage levels go down, you can scale that back down so that your usage, your consumption follows the amount of capacity that you've deployed at any given instance in time, right? And that's part of that efficiency we talked about before. And so in the cloud, this ability to have those services spin up and spin down almost completely automatically in some cases really is a true benefit that you get in the cloud that would be very hard to create in your own data center. There are some things you could do in your data center that could replicate that a little bit, but not to the same degree or capacity that you have in the cloud. Security, and this is a big one, and this is one that has been pretty near and dear to my heart for quite a long time, coming from a security background, having worked at the Pentagon and as a security analyst for a while. And the number one issue that we had with security when I was at DNN for many years was the fact that it didn't matter how many security fixes we released. It didn't matter how on top of vulnerabilities we were, squashing 0 days when they came out. All of that mattered for naught if our customers weren't actually deploying those updated services, if they weren't actually deploying that updated code. Because while, yes, theoretically, the latest version of code is the most secure version, often we would find customers that were 6 months, a year, 5 years, 8 years out of running the latest and greatest code, which meant that there were massive security vulnerabilities that not only had been discovered, but that had been published, had published exploits, and all of this. And then they would come to us later and say, well, I was just hacked. How come your software is so insecure? And it's like, this is the problem that you have with software. You can never catch everything. You try, but the reality is there are bugs, and some of those bugs result in security vulnerabilities. The benefit that I think from a security perspective in the cloud, one of the strongest that I see, is this idea that those cloud providers are continuously deploying the most secure capability that they can within their environment for the services they provide. This means that as vulnerabilities are discovered, they're able to deploy that on a just-in-time basis, so that you're always running the most secure version of the baseline platform software. Now that's, again, that may be a oversimplification. It's not always the exact latest and greatest, but from a security perspective, it is as close to that as you will see in any data center for most applications. And I've worked with a lot of different organizations from DoD to many others, and I can tell you that even the most stringent security people still have trouble keeping up with security patches and keeping those deployed in their own environments. So the benefit of the cloud and their ability to keep that deployed and keep a secure environment available for your use is a huge benefit in my mind to being able to operate in the cloud. One of the other things that and this was a question that came up earlier in the Q&A, was this idea of, is there benefit in the cloud, or is there benefit for security purposes for most organizations for running on-prem or in their own data center as opposed to running in the cloud? What are the security implications of that? And I would say that for the most part, the cloud providers today have addressed almost every security concern of these organizations, whether it is the data location concerns and data transit concerns of countries like or political entities like the European Union or Germany or different countries that worry about what happens if their data leaves their political boundaries and is now subject to access and seizure in some other country, right? Think about what it would look like if your data was transiting through servers right now that were located in Russia, and how secure you might or might not feel if that were the case, right? So some of those concerns have been addressed. Concerns around meeting various security requirements, and there are many that are out there, and depending on your industry, you may have very specific security concerns. And I know most of the major cloud platforms, certainly Google, Amazon, and Azure, all address most of the major security frameworks and requirements, whether it's PCI, DCSS. There are a dozen other security requirements and certifications that are required that talk not just to application isolation and security of the underlying platform, but also security of the physical infrastructure that is running that platform, right? All of these, if you were hosting it yourself, are huge costs and expenses for your organization to try to deal with. Now, many large enterprise organizations, think of banks, think of insurance companies, think of hospitals, healthcare organizations. They all have very special and very specific security requirements. And I know that the industry as a whole have addressed most of those major requirements. There may be a few outliers. I'm not aware of any, but there very well could be a few outliers. I think the biggest factor hindering adoption by some of these more security conscious organizations is just the feeling of the loss of control, right? It's that idea that if it's in my control, if it's in my server, if it's in my data center, then I can know for certain that who accessed that hardware, who accessed that server, who loaded what software on, maybe in the background of that server. Whereas if I'm running in the cloud, I don't even know necessarily what server my software might be running on. I don't necessarily know specifically what data center it's in and how secure or not secure that might be, right? So it's more of a perception than a reality thing in terms of security. I think from a security perspective, the cloud providers are doing as good or better a job than most of the enterprises that I've seen. Okay, so these really are the core 4 areas that I see as the main benefits of cloud computing. There are others, and depending on your industry, depending on your application needs, there are certainly many other benefits that I'm not going to cover here today. So these are just a handful. So let's talk about what it really means to build cloud native applications, though, because one of the things that I learned in moving DNN to the cloud was our architecture was architected in a way that we were very specific to wanting to know directory paths and having direct access to hardware or to hard drives and knowing exactly where files were stored, how they were stored, what the relationship was to the application, right? And there were a number of things where it even got down to we had to know all of the number of servers in a server farm and what they were named and what the IP addresses were. And it was very much a non-scalable from that perspective, or non-automatable process to scale up and scale down. It still was a very manual process if I wanted to add a new server in or take one down. Even though I was running in the cloud, I wasn't taking advantage of a lot of the benefits that the cloud offered. It was a very static environment running in the cloud. I could scale it, but that was still took a lot of manual steps in order to do that. And so when we talk about cloud native, we're really talking about building apps in a way that allows us to really get the full benefit of the cloud, full benefit of that scaling, full benefit of elasticity, full benefit of the security. If you think about it, if I run a virtual machine in the cloud, right? So I install my own operating system in a virtual machine, Amazon, Azure, Google Cloud, it's all the same. None of them knows what's inside my virtual machine. If I have an old, insecure version of the operating system running inside that virtual machine, I will be insecure by default, right? So they don't provide any sort of security guarantees once you go inside that virtual machine. So that's an example of how I might be in the cloud, but I'm not really cloud native. I'm not really relying on the capability and benefit that cloud's going to provide. So a number of cloud organizations, cloud-based organizations, SaaS software providers, they've been in this space for quite a long time now, for going on 15, 20 years in some cases. And they have sort of started to gel around a certain definition, around certain concepts that they've termed cloud native, right? And there's even a cloud native computing foundation and this is the definition that they have. Now, I would strip this down a little bit further, right? I would strip this down to just the first half of this statement, because I think this first half really talks independent of the underlying implementations, and really talks to principles that have been fairly consistent throughout the last decade, at least in the cloud, and the scalability and dynamism of building in cloud native are two of those main components, and we'll talk about more here in a minute. But for this purposes of this definition, right, it's really that ability to build in a modern way, in a modular way, and modular being sort of that analogous to dynamic environments, right? Dynamic apps running in dynamic environments is probably a better way to say that. The other half of this, kind of the grayed out portion, right, really speaks to some of the tooling that we would use to implement this scalability, some of the tools we would use to implement these dynamic environments, but they're by no means the only way to deliver cloud native applications, right? Containers and service meshes, microservices, immutable infrastructure, and declarative APIs, right? Those are really implementation specific, and I would say if you come back in 5 years, that portion of this definition may very well change, whereas the first half of this definition likely will not. So one of the things that as we move into cloud native, and this really is a attribute of the cloud, but it's something that if you want to build cloud native, you kind of have to think about this almost from the very start. And that is this idea of statelessness. If you think of a notepad, right, I can grab any sheet out of that pad of paper and I don't care. They all provide exactly the same services. If one of them gets smudged, I can rip it out of the notepad and move to the next sheet and I have still the same capability, right? If I start adding state into that notepad, if I start, putting my doodles in there and writing words down on a page, those pages now have state. They now have data associated with that page. I can't readily duplicate or copy that page and use it over and over and over again, just because I can't just grab 10 other blank sheets out of that particular notepad. Now I have to go and create a special notepad that has 10 copies of that particular sheet and hope I made enough copies that I need of that doodle or of that headline, right? So the more state we start introducing into our apps that are kind of tightly bound with our code, the more problems we're going to have trying to scale up or scale out, right? Scaling up probably be okay, but scaling out, making multiple copies of our service or our application containers becomes very problematic when we start introducing state into those environments. The other part of scaling is to have redundancies built into the system, right? Think of a herd of cows, a herd of cattle, right? If I'm getting milk from this herd, right? If any one of the cows gets sick and I have to pull it out and it's no longer providing milk, right? I've still got many other cows that are able to provide milk for morning breakfast and for the other people in the community, right? So I haven't lost that capability. Yes, I may be a little slower. I may not provide service as quick, but the service is still there, right? This redundancy allows and is key to that reliability we talked about earlier. And one of the things that we often talk about in the context of the cloud is this idea of we want to operate cattle and not pets. If you go back to the old into the 90s and early 2000s, where we had server rooms, right? And we often had servers, and we often gave each server a name. Oh, that's the USS Enterprise, and oh, that's some other ship that we named, or whatever the names you used in your server room. Right, we started naming each of these servers, and then we started realizing as we moved to the cloud, wait a minute, I need to kill that server off because it's unhealthy, and I'll just spin up a new one. Well, in the old days with our data server or with our servers in the back room, right, we didn't think about killing it off because that might have been $50,000 worth of investment. So we would spend hours and hours, weeks and weeks trying to nurse this thing back to health, hoping that we could get this server back up and running, right? In the cloud, we don't think that way. In the cloud, we know that we can spin up services and spin down services in a matter of seconds or a matter of minutes. So we don't worry if one unit, if one of our servers goes bad, if one unit of scale goes bad, we just spin up another one and take the first one down, right? And in fact, many services that are available in the cloud today will do that automatically, and you may not even know that occurred, right? It will just happen, and your service, your application will continue to run if it's built in a cloud native way, because you're not dependent on running on the USS Enterprise, right? You could run on any of the other ships of the fleet and you would be just fine because you're treating them as cattle, not as pets. The other part of this is not just about being redundant, but it's also about being resilient. And for those who are a little more seasoned, you may remember the toys from the 1970s called Weebles. You know, the piece was Weebles wobble, but they don't fall down. And that's exactly what we want to have with our cloud applications. We want those applications to be resilient so that if there's a failure, if there's an outage, if a service is interrupted, that the application can continue to run. It may run in a degraded capacity, but it's still able to provide value and service to the customers, maybe just not everything. When we built out our service in DNN, one of the things that we did is we used a lot of loose coupling and a lot of message queues. And even if some of the services went down in Azure, I remember one time we'd spin up a demo service that would give customers a demo instance of our app, and it was all spinning up in the cloud, and we used messages. So a customer could come to the website, they could request a demo instance of the app, and it would spin one up and give it to them. And if for whatever reason Azure went down, as it has done many times in the past decade or so, it was fine, because usually it was just one or two services in Azure that would go down. We would still get the request come in on a message bus, and it would just hang out until the app was back up and ready to be serviced. And we would pull the message off the message queue, process it, and then hand the customer their demo instance. The customer didn't have to wait around and retry to request a service. It would just automatically happen, and maybe it was delayed by 20 minutes or 30 minutes or a couple hours, and eventually they would get their demo instance, right? And that's one example of this idea of building applications so that they could gracefully degrade and then kind of pick themselves back up and resume as soon as everything was ready, right? So those are just a few key factors as we start talking about how to build cloud native. The industry has kind of come together, and the second half of the cloud native computing foundation, their definition there really talks to some of the concepts that have been coined, the term 12-factor apps. And 12-factor apps really describe 10 aspects of building cloud native applications, or building applications in a way that are deemed cloud native. Now, some of these may be very prescriptive and say this is what you should do. Others are more loosely defined than that, and they don't say you have to use this kind of service, but they say this general capability, right? And so the first of these is around code base, and it's around this idea which most of us have been doing for the last 30 years, which is a single code base under source control, right? And version tracking of that code base. You can think of services like Azure DevOps, the GitLab and GitHub and some of these other services that allow us to have access to version control. In this day and age, there are free services in almost everywhere you look where you can host code and have version control and source control with a lot of security around it for your code base. So there really is little reason not to do this, even for the most trivial of code. Number two on the list is around dependencies. And this is the ability to explicitly declare and isolate dependencies in our application, right? And if you think about this, the way we build most modern applications now is really we've componentized most of these applications, whether we're writing in Ruby and using Ruby gems, or we're writing in Python and using PIP, or NPM in JavaScript and Node. Almost every major language that's out there today has some sort of package management system that allows us to say, I am not only going to write my own code, but I'm going to take dependencies on a lot of other pieces of code that provide some service or capability to me. And at the code level, that's great, but it goes beyond that, right? If you start looking at infrastructure as code, right, we can start declaring the types of dependencies that we need in terms of infrastructure services, right? I need a SQL server in one instance, and I need some sort of a message queue in another, and I might need a state, like something like a Redis cache in another server, and then I'm going to need a web service on another instance of a service or a container or whatever. And I'm going to start declaring what all those dependencies are at the hardware infrastructure level, right? And I'm going to use something like ARM templates in Azure, or I'm going to use something like Terraform or some of the other management applications for declaring explicitly what are all the dependencies that my application has. Configuration. One of the things that makes us very stateful in our applications is configuration. Oh, what I'm running in the dev environment, I need to know how to talk to localhost. Oh, I'm running in the production environment, I need to know what the production endpoint is for hitting this service, right? All of those start to become state that is accumulating inside of our application, and that limit the ability of us to run our application, whether it's in production or staging or some test environment or our local development environment, right? We want to eliminate all of that state out of the application, and in many cases we do that by running some sort of a configuration. We might put it in environment variables. If it's really sensitive data, we might store it in some sort of a vault. If we're running on Azure, that might be Azure Key Vault. There's similar services on AWS and Google Cloud as well. Finally, the backing services, right? So maybe we're running SQL Server. Well, the SQL Server that I run in the cloud looks very different than the SQL Server that I run while I'm developing on my local machine, right? But I treat all of those services, whether it's in the cloud or on my local machine, whether it's in dev, staging, test, production, they're all treated the same, right? I may run on my dev machine, I may run an in-memory database rather than spin up a full-blown SQL Server, right? But from the application perspective, I'm going to code it so that it doesn't matter to me which version of SQL Server I'm hitting, whether it's SQL Server in a virtual machine, or SQL Server running as a SQL Azure service, or SQL Server running as an in-memory database instance on my local machine. So those are examples of treating those backing services as really attached resources and not caring about where they actually live. And if we've done step 3, if we've done the third factor correct with configuration, then it's easy to change a couple of environment variables to point our application to the appropriate backing service for the environment that we're currently executing in. Number 5 is build, release, and run. So we're going to strictly separate out each of the different phases of our application, and we're going to control those so that our build environment is probably not the same as our runtime environment. I often use what's called continuous integration, continuous deployment platforms for doing my build services. And I may spin up a certain size unit or compute unit as part of that continuous integration in order to run some tests or to do something in that build process, right? But that is not a runtime. That is not my production service. I'm not running tests as part of my build process against my production servers, right? I'm doing that in sort of this controlled environment. And then when I'm ready to do a release, I'm taking that code that came out of build that I said was good. I'm marrying that up with configuration that I have in one of my systems, whether it's environment, whether it's one of the vaults for some of the critical secure data that I need, and I'm marrying those up, and then I'm deploying that into a run environment, into a production environment, or staging, or whatever environment I'm deploying to, right? And those are all separate processes running in separate locations. That release that may be part of my CI/CD pipeline, often it is a separate stage of CI/CD. Sometimes that may actually occur when I spin out or spawn out to a Terraform service or some other service to actually bundle and deploy that release. Okay. Processes. So when we're running our application, we run our application as a stateless process, and we scale in terms of processes, not in terms of how much memory I have in this one process, but let's take one process and turn it into two. Let's take two, turn it into four, right? And so I scale out rather than scaling up, because once I start scaling up and that becomes my unit of increment, a unit of scale, I will quickly hit some limits in that in the scaling up. Now you may decide that my base unit is a 4 CPU compute unit, right? Someone else may decide my base unit is a 1 CPU compute unit or 1 virtual CPU compute unit, right? And their unit of scale is 1, and my unit of scale is 4, or maybe it's 8, or whatever that is. And maybe they use a gigabyte and I use 8 gigabytes because I know that chunk kind of matches my units of scale that I need for my application. Okay. The next area out of these 12 factors is around port binding. So often we run a lot of services as part of our application, and each service is exposed via its own port. This is something that's more true in the Unix and some of the non-Windows environments. Typically in Windows, many of the services we run have well-defined ports, but typically your application is going to be exposed over one of those well-defined ports, and it may consume some services on the internal networks, virtual networks of those platforms across those other well-known ports for things like SQL Server or for Redis caches or what have you. Okay, and finally, number 8 here is around concurrency, right? And again, this talks a little bit to the processes from before, but our method for scaling is really around scaling the number of processes, not around scaling capacity within a single process. And then the final 4 that we'll talk about is factor number 9, which is disposability. And that is we define and we build our apps so that they are very quick to deploy, very quick to spin up, and very graceful when they shut down. They take care of the process, they take care of the resources they're consuming, and they spin them down in a very controlled manner. And when catastrophe happens and one gets spun down where it wasn't controlled, they gracefully handle how to deal with whatever state or whatever information may have been lost as part of that shutdown. Okay, dev prod parity. So this is one we talk about a lot and have talked about a lot as long as I've been a developer, where the development environment is supposed to look like production environment, but the cost for doing that is often prohibitive, especially when you were talking about running physical servers. We often would have 3 or 4, pretty beefy servers in production, or maybe more, depending on the application. And it just wasn't realistic for me to have 3 or 4 servers sitting at my desk, right? But now with the cloud, it's very cost efficient for me to spin stuff up for 10, 20 minutes, run some tests, run my application, spin them back down. And the cost for doing that is pretty minimal. So it is much easier today in the cloud environment to have this dev prod parity, or something closer approximating dev prod parity than we've ever had in the past. And again, keep in mind this is where we want to be as similar as possible, still recognizing that we're never going to be 100% the same. Logs. So a lot of us write log information in our applications, and often we write these logs and they go out to files. And the problem is, when we do that, often these files sit on a disk somewhere, and we keep writing to these disks, and we keep writing these logs, and eventually the disk gets full and someone says, oh, we'll just go clean out the logs, right, and get rid of all those old logs. We don't need them anymore. And then 2 months later, you get hit with a security intrusion, right? And then everyone goes, well, let's go look through the old logs and see who's been hitting our application, and who's been in our application, what they've been doing, and maybe we can reproduce and kind of trace back on what's been going on in terms of the logs. And you find, oh, we don't have those logs anymore because we got rid of them 3 months ago, right? And the relevant logging information just wasn't stored. With the advent decade or so ago of services and companies like Splunk and others, and now we have App Insights, we have Stackdriver, we've got any number of services out there that are available that allow you to stream your logs to these services and store them in the cloud, and keep months and months, years and years worth of log information, so that if you should ever be in that situation where you need to recover, where you need to trace back and have this audit capability, you can do that readily and easily. And the last factor is one that really I haven't run into a lot in the apps that I run, but when you have one-off processes or one-off tasks for admin purposes, those should be deployed as part of the application. Typically, you'll see this as REPLs or other things where I need to SSH into a server, run some task, and have it update some process on the server, or maybe pull down some process on the server. So if you hear about this 12th factor, for me, this has not really been one that I've been concerned with in my development experience, but it is one that is part of the 12 factors. So it's definitely something you should look at and see, is it relevant to your application? And that concludes my portion of the talk for today. I appreciate everyone joining us for Lunch and Learn. I will stick around for a minute or so if people have questions. I don't know that we have any that have come up, but if there are questions that people want answered, I'd be more than happy to do that. A few of the resources that we have available, that much of this information for this talk can be found both in up on Microsoft Azure. They've got a great book that goes into a lot of depth and detail on building cloud native apps for Azure. Also look at the 12factor.net for a great discussion around 12-factor apps. But thanks everyone for joining me today. I hope you got something out of the talk, and if you've got questions or whatever, you can always reach me by email or on LinkedIn, or come to improving.com, and we would be glad to have take the conversation further.
Thank you, Joe, for your presentation today. I know that everyone got something out of it. I certainly did. I would like to remind everyone that we do these improving talks every Friday at noon Central. And so please think about coming back and joining us next week. And we will be looking forward to seeing you then. Have a great day.